Yogesh sir, I think we can start now.
Okay. Before that, I'll
And,
just take a photograph of all, or you will take the photograph?
yes, sir. I think a few are yet to join. So at the end of the session, Himanshu
Will.
will take a snap. Himanshu.
Okay. Yeah. Himanshu.
Himanshu. Himanshu, are you there?
Yes, sir, I am there.
Yeah.
So at the
So,
end of the session, just ask everyone to put on their cameras and take a snapshot for record purpose.
It's a request to all, please on your cameras.
Not now. At the end of the session when everyone
Okay, sir.
has joined.
Sure, sir.
Okay. So Himanshu will send you the snap, sir.
right. Yeah.
Okay. So I'll take a leave now, and you can continue.
Okay. No issue. I will conduct the session.
Himanshu, if there is any problem, you can text me.
Yeah, absolutely. So good morning all. So I'll be taking a session on industrial DMAC project. So basically how we are taking this Six Sigma journey for the project. This is a live example of that. And this project we have completed in FY 17-18 when I was there in Dr. Reddy's. So we all know you have gone through the theories about DMAC process. So define, measure, analyze, improve and control. Now, how this DMAC philosophy you are utilizing in project, that we will see with the project, and what benefit we have got it from that we will just see. So basically, define phase objective, as you have learned, it consists of first primarily defining a problem, because if you define a problem properly, you will improve your target with the clarity, right? You have to identify the customer. Earlier, I have given earlier lecture. I have given the example how how we have to satisfy our customer, because customer is a prime focus for us. Now, doing a project, who are the key stakeholder for that? So that we have to define. Then, team is always important for doing Six Sigma projects. So we have to identify our team and organize a kickoff meeting before starting the project, right? So that whatever concerns are there, we can very well know about that and we can take care in our project. Analyze stakeholder support, collect expectation from the project. Stakeholder analysis you have to do. Who will support you? Who will drag into the trouble? That analysis we have to do and find out who will be the give win-win situation for our project. So that kind of people we have to recognize and we have to keep in our team. The members who are objecting our project, we have to give them a positive feedback about how this will be beneficial and bring him to our party. So that stakeholder analysis is very important, that we have to do it in the define phase. Set boundaries and map for the process. So always process is sometimes it's big and everything we can't change it within a few seconds or few period of time. It requires a longer time. But the problem phase or problem point, we have to trigger it and find a solution for that. So whenever you take a project, we have to set boundaries for completion of that project. We can't do other than that problem. We can't solve everything, right? So we have to define a project, define the boundaries for the project, and we should know the exact process map for the subjected targeted project. Now VOC, voice of customer, is very important for the project. when you are dealing with a DMAC or Six Sigma project. What customer says that you have to translate into the CTQs, critical to quality. What customer want and what we want to deliver at the end of project, that is very important. And then after doing everything, we have to identify the quick wins from that. Quick wins, we have to do 5 years. The least I will just give it. Okay, you want to do it. So that kind of thing we can do. Is that problem easily solvable or it requires data analytics? So that we have to clearly define. So this is just objective of define phase, what you have to take it forward. Now you are also having the project charter. So this is a project charter for the project what we have conducted earlier. So there was one product, its OTF is less than 85%, and we will not getting the capacity of that product. The capacity of the design capacity was 130 metric ton, but we are not getting it. We are lying below 130. Our baseline was 104, and there was a 100% demand from the Mexico plant, which is having a capacity more than 130. So supplying that material is tedious job for us because always their plant capacity was unutilized. So we have taken this project, and the tangible benefit from that, the 44 crore per year of revenue is added to that chemical transformation unit, CTO. So we have thought, okay, we will take this project because it's having the benefit of 44 crores per year. And how we can deliver, we'll do a DMAC project for that and give the solution. So we have taken a target of 130 metric ton per month as per the design capacity and supply to the Mexico. That is our goal statement. Now expected sponge benefit, we have to also write because apart from the hard benefit, there are few benefits which are very important because if I deliver 130 metric ton, that will utilize the capacity of that Mexico plant, that American plant, and hence there will be a win-win situation for them also. They can cater to the market. Then we have to have a team roles for that, responsible, accountability, supportive, who will be there, inform and consultant. Then we have to give the timelines for our project, which also first is when the project was recognized, then DMAC project schedule. So this is about the project charter, and always we have in business case we have to give a timeline when it was hindered or it was seen as a project, and for according to that we have to give a baseline. SIPOC is very important while doing a project because it consists of suppliers. Who are the supplier for getting a material? Is there any delay of getting a raw material to your process? That we have to find out. Input, what kind of raw material or resource you are using it? Is there any problem with the resource? So it will come into a supplier. So it will standardize what you require. Process all the activities you are performing with the process that you have to put in and find out which activity is the critical one. Then the output from the process, define the output. What output you want? Like in this project, it's like a capacity enhancement from 104 to 130 metric ton per month. So that was the output of that product. And the customer, who is your customer, who you want to satisfy. So that SIPOC, if you prepare properly, you will understand the linkage between all these 5 steps, and from that some ideas will be triggered, and that will be leveraged or utilized for further processing or further analyzing of the data. We have to define our customers. So what there will be an internal customer. What type of customer is it? Business process that you have to define. Then designation role. Responsibility is very important, right? If that person is not available, then who is the delegate team member who will give the information or who will do that activity? So if you see the customer and its delegate to get fetch a voice of the person is very important. So we have to define the internal customer. Then very important is the team charter. In team charter, we have to give what is the responsibility, accountability of that person, and from which department he is belong to. So if entire information is there, you can have and you can catch the person to get the data or do your work. So it is clearly defined. Everything is clear. Who will do what at what time, right? Then comes the VOC. In VOC, there are tables and the question we have to ask. Customer name we have to write, and what did customer says? Voice of customer. What he wants. Like in this case, the maximum plant wants the capacity to be enhanced to 130 so that they can use that product and have the utilization of their capacity to 85%, right? Earlier it was less than 80% or 75%, so that they can deliver the maximum amount of product and cater to the market. So that was the voice. We want 85% capacity utilization. Now how we want to do that? We have to convert from VOC to CTQ. Similarly, the question comes Kano analysis. You have studied the Kano analysis. I'll just show you the picture of it. So you can, this is the Kano model. In Kano model, you can see the 4 quarters, right? One is the absent, satisfaction, fulfilled, and dissatisfaction. Now, take an example of mobile. Earlier, mobile were for taking a call, right? Now, we were the use of mobile, it is fulfilling our requirement in the earlier days. Now, era come that multimedia is there. We can see the VLC videos, pictures. So our need increase. When there was a limited need, then when we used to get a call and we used to talk with the person far in Delhi or Calcutta through a small set, that's called mobile. But now the use of mobile increase, we want to see picture on that. So that feature is added into the mobile. So need became wants, right? Now this is a want. It will have a 12 megapixel camera. You can click a picture. But there are few phones where fulfillment wants, must and wants we have clear with the small phone of say 10,000 to 20,000 rupees. Now the people excitement increase. Oppo come with 64 megapixel camera. That is excitement, right? You can have the image processor in that. Good quality picture we can get it from the Apple phones. So that is the exciter. So whatever need is there, that we have to satisfy with this Kano model. What is a must in this project? For me, the must is the capacity utilization. So that is a must. I should fulfill that. I will not go with the excitement or wants because that will add the value or cost to the customer. quality and productivity I will maintain, and I will fulfill the demand of the customer. So I'll go with the must. So this Kano model, you have to do it for your project. So what customer want? He wants excitement. So you have to give excitement with the added cost. Whatever wants he has, like good quality material, or there should be highly 99.9% purity he wants, but we can produce 99.9%, he will give extra money for that. Then your project will go away from the wants need that quarter, right? So it's about, we have to understand the Kano model, what customer want, what is the need. I have already told that we have to utilize 85% of plant capacity at maximum level. So where is the need felt, that we have to find out. Where is the need felt, why is the need felt, and how the situation is handled now. So we have to give entire thing. From that you will define what kind of CTQs which you have to target for this project. And then you take a different type of customer department and take a voice from them. So taking a voice of customer is very important for the project. Then you convert the voice of customer to CTQ. What he said, 85% of the capacity should be utilized. Now what is their capacity, you have to find out, and from that you back calculate the capacity, and what is the capacity currently moving, that you have to convert into CTQ. CTQ is the number or metric which will give you the formula, right? And that formula you will justify your final product or final project objective. So if this part is very important, we should convert this voice to CTQs, critical to quality. So these are the various metrics we have developed to get that 85% of capacity utilization. Then prioritization we have done. It is very important to do prioritization. Always remember, any issues or any problem you have to divide into 931 analysis. What is a 931 analysis? It just, we are having 1 to 10 numbers, right? 10 being the largest, like feedback from what we are collecting, like that. So why we have taken 931? Because 9 is the most highest, 3 is the moderate, and 1 is the lowest. So what will happen whenever you give 9? So you will have the greater number with your side, and 3 and 1 will be the lower. So moderate risks can be easily identified and lower risks. If you have 1 to 10 number of data, there is some mismatch, because you have to identify from the 10 numbers which is the largest. And if someone gives 5 to 6, you can't able to find it out or prioritize your ideas or the activity what you have to perform. For that, 931 analysis is very important. 931 is the number, 9 being high and 1 being very low, and 3 is a moderate. So within the 3 level only we have to prioritize our ideas. So that will be the effective way. And then we have to prioritize idea based on who is having the highest number. So from this project, there is one idea which was very important to produce and plan activity for the plant. There were downtimes in the process that will just come into the later part with the analyze phase. So now you understood that you have to increase the capacity of the plant, and that capacity will come from our major phase. What is the actual capacity that that plant is producing? So quick wins are like this: threads of similarity. Threads of similarity is what you have done earlier Why you are not transforming that or carry out same operations now to reduce that cycle time? Why you are not doing that or not achieving that? That will be coming from the threads of similarity. There was one example that somebody has given to me in my training period. There were two hospitals. One is a government hospital and another one is the private hospital. Now in government hospital, what happened? There was a scheme, government scheme, which used to give the support to the patient, and that money given to hospital in lower time to that hospital. But mostly this private hospital were not able to transform this money from government to that hospital within a stipulated period. So there is always a lag. So then the hospital management had decided, why this they are adopting same process, but they are not getting the result, desired outcome. Then they decided to see how the process is going on in the government hospital. In government hospital, they have deputed one person and they have done these threads of similarity. So they have seen the process, how it is going on. What they have done in the government hospital is the local doctor they have appointed over there, and the people or patient who is coming to that hospital, who is giving the information in the local language, and it is easily transformed into the medical terminology. So because of that, the data which was submitted to government, and they were satisfying all the condition, and the money is transformed to the government hospital. But if they have seen the situation in the private hospital, it was seen that the MBBS doctor who is not conversant with the local people, not able to transform the data in the correct language, and because of that there was a mismatch between the therapy or the treatment they are doing for the patient, and because of mismatch the government is not allowing fund for them. So then they have done the similar threads of similarity. They have appointed local doctor, and then the timeline was reduced, and they are getting a fund from the government at the regulator. So in this example, what we have seen, the similar thread they have picked up and just put it in that deviation, and they have attached to that, and they are getting the proper outcome, right? So these threads of similarity, we have to find it out. Whenever anything, like we are cooking some good food, right? So what we are doing, whatever they have performed, same we are performing at our place and getting a desired output. This is called the threads of similarity. And whenever there is a deviation and there are two processes which are going, one is giving good product, other is giving bad product, then we have to see the same thing between them and find it out the dissimilarity and make it similar, and you will get the desired output, right? 5S, you know, the 5S, what is 5S? First S is segregate, right? Set in order, shine, standardize, and sustain. So whenever there is a process, I will talk to you in the next lecture about 5S. But whenever there is, take an example of your home kitchen. If everything is scattered, your masalas, then dals, and sugar, and salt are segregated, you will not find it easily. Sometimes you will keep will put in your tea salt. Sometimes you will put sugar in your food. So you have to segregate. First, you have to segregate all the items, right? Then put all the items. Segregate means whatever needed one is there, you just keep it. Not needed, you just throw it out. Or if you are using it afterwards, then you just put it into your shelf. You will require it later. So you'll keep it that. Which is not needed item, scrap item, you just throw it off. It's not required. Now set it order all the items for making a tea. You just keep it to one side. Dal, you just keep it to one side. Then masalas and salt, you just keep it to other side, so that there will not be mixing. Then comes shine. Always keep clean, so there should not be a dirt. Fourth comes standardize. You make a rule that every day at 5 p.m. I will clean. I will just see at the end of day. I'll see everything is placed or not. Whatever I have taken, I have put into shelf or not. That is standardized. You make a rule for that and sustain. Every day you just perform same thing. So everything will be done. And the 6S is the safety. S for safety. So everything which is placed, it is properly placed. Whatever knife and other sharper tools, what we are using for the cooking, that should be kept in the proper way. So we have to see that our gas stove is properly put off after work. So that kind of thing we have to take it in the safety. Similar way, our mother, our wife is doing day-to-day activity like this only. That's why nothing is happening at the kitchen spot. Similar thing is happening in the shop floor level also. So this 5S concept, it's utilized. Spaghetti diagram, you have to find the process. Mainly it happens in the office project, that you have to draw a diagram and there are 3 steps, and how that 3 steps are happening, you just make a line graph for that. So that's called a spaghetti diagram, and we see the movement of that process. Value stream mapping is an important tool which will find the waste. Earlier we have studied about that. 8 type of waste, T modes, right? So it will find out the waste from the system, and we are eliminated that. Then create a process map, and then FMEA we are doing for the as-is process. Failure mode effect analysis, I will show you that. Pokayoke mistake proofing. Best example is the pen drive what we have. It will go in one direction only. If you put in the other direction, it will not go, right? So that is a Pokayoke. Then update to process map. So these are the quick things what we have to do in the define phase. Then the measure phase come into picture. Now we have defined the CTQs. Now the CTQs data, we have to collect the data for our CTQs. Now we have to make a collection plan for that. Now whatever data we are collecting, that data which is coming from the measurement system, is that measurement system is valid? That we have to find out. And that can be done with the measurement system analysis tool. So this is one of the important topic which you need to be, when you go for the higher belt, like green belt and black belt, in that case, this measurement system analysis is very important. Why it is very important? Because whenever you go for the collecting any data, the question comes that whatever data you are collected, is it valid? Now you will ask me, is it valid means what? Because the weight, what we are collecting, it's just a number. Have we calibrated that with the standards? So whatever weight we are getting, is it same what we are intended to do? So whatever temperature, pressure, and flow meters, base scale, entire thing calibration should be there, and there should not be error higher than 10%. For measurement system analysis, this is very important. And this, here we go with the gauge RNR study. So in gauge RNR study, what we are doing, we are analyzing repeatability and reproducibility, which is very important. Repeatability means the person who are taking a data should give a data, same data, or the variation should be less than 10%. Repeatability, when you are utilizing a data, right, and the variance between that instrument should be lesser. So overall data variation should be less than 10%. 10% is very good. 10 to 30% it is also acceptable, but we have to find out the reason for that, why it is data is varied. So there we have to do FMEA, this fishbone analysis for that, find the probable root cause. Then comes the process capability, PPK and CPK value. So process capability should be more than when we are doing the project and we want to find out, it should be greater than 1.33. So that will give you a 4 sigma level capability. So that will be shows the improvement. In the if you see the aeronautical processes, there the process capability is high up to 5 PPK value. So that process capability we have to find it out. Then for CTQ, we have to do, after doing the measurement system analysis, we have to do a baselining. Baselining, for doing baselining, it is compulsory that we should have 1 year data for that. 1 year data we have to log, and that we have to capture with the control chart. I will show you the control chart for that. So this is a Pareto diagram for data collected where the process capability is going down. And this is a control chart. You can see, very well see the FY16, what was the timing for the certain reactor, right? So this kind of graph you have to put it. So where the capacity is going down, we will come to know. Then comes the normality test. Normality test is always important that data should be normal. It should give the central tendency. If you see the data over here, it is skewed. It is not normal. That's why this, if you see the value over here, if you see, I will just show you the through pointer. If you see the value over here, it is less than 0.05. That means data is not normal. You see, the data should lie on this line always. So then you can find the central tendency of this. You will get an average like this. So this will be the maximum and it will come over here. But if you see, it is skewed to one area, left corner. That shows data normality is not there. That means you are getting sometimes lower, but sometimes it is going for the higher. So we have to find the reason for that. So we have to bring it to the central tendency at the center. So this is the USL. So it should be like peak is at the center and then end at this dotted line. Similarly with this. So if you see the PPK value is very much lower, 0.26, 25. So we have to improve that. That means there is an irregularity between the process, these three processes. that we have to leverage. Okay? So this is about the major phase. So you know what is your baseline and what you have to improve from where to where, right? So you have set up the target. Then comes the analyze phase. In analyze phase, we have to go with the potential root cause identification. Then from the root cause, we will go with the XCDQs, that is probable root cause for the main root cause with a 5Y analysis, and convert our probable root cause into XCDQs. Y is our main CDQ. With the fishbone, we are converting that into XCDQs, right? That is smaller parameter which are affecting our process to go delay. Hence, our production is going down. Then convert this XCDQs, analyze excess using control chart. What is the issue with that? If required, you do regression analysis for that and find brainstorming with the people and find out the solution for that. Okay, why it is happening? Then prioritize action plan. So these are the steps what you have to utilize. Now we will see the result for that. So like this, we have to do the fishbone analysis. This is one of the stage where this is a stage, ASP stage, where the material is generated, the product is generated, and personal, machine, method, material, measurement, and environment. These are the root cause, like civil manpower, absenteeism, maintenance of manpower availability, delay in charging of material, then quality of material will be the picture, because if the quality is not good, it will take a longer time to convert that material into the product. Then method, what kind of method we are utilizing. So there are TLC method, brine temperature, then again type of charging, the way in which we are charging the material, right? So these are the various effects. Also environmental effect is there. In summer, in particular region, the temperature goes up to 48 degrees Celsius. So that will have an effect on your utility system. So utility system temperature goes higher. If you are having a brine plant which is delivering at -5 to -10 degrees Celsius, but because of cooling water temperature is increasing, it is not able to condense that liquid to that temperature. Hence, you are not getting the brine temperature below 0 degrees Celsius. So that issue. So it is not able to take the load. So this kind of system you have to do. This kind of fishbone diagram you have to do. And this, whatever prioritize cause effect is there, that you have to take it into the 5Y analysis. So I will just show you the this is about are you able to see the this? I will just show you the YY analysis.
Yes, sir.
See the screen?
Yes, sir. Yes, sir.
Yes, sir. So this is 5Y analysis. You have to do it for the all the causes what we have noted in the fishbone. So we have to give 5 times. We have to ask question why it is happening, why it is happening, and then at one why you will come up with the solution, and that root cause you just write it over here. So keep on asking why, unless and until you will not ask again why for that question. That is the termination for the YY analysis, right? And then it will come as your corrective and preventive action. So it's very easy. So this kind of YY analysis you have to do. Okay? So again, I will coming back. From that YY analysis, we have to prioritize our action plan. So whatever root cause is there, we have to prioritize, and we have to prioritize in the PARETO diagram, and then which is the critical one having the highest value, that you have to trigger it off, or we have to take it as the priority base. Okay? And then here, once you will get all the prioritized root causes, you have to go for the implement plan, and implement plan will be coming into the improve phase. Now here, whatever solution we have identified, this will be validated, right? And in the improve phase, we have to do a pilot for that. Find out how we can improve the process. This is the implementation stage, right? Here, we are going to see whatever root cause is there, that action will be converted into the implementation, and you will get the result of your whatever analysis, what you have done in the define, measure and analyze phase. So this kind of improvement tracker you have to put in, right? Improvement, finalize, responsibility you have to give, implementation status and expected date of closure, because this is very important when we are doing the project. It's like a project scheduling, right? And then you have to do whatever improvement you have done. Now we have to do the FMEA, failure mode effect analysis. This will give you, if you are doing this improvement, it gets failed. Why it is getting failed? That you will come to know the exact cause for that. And that cause you just have to eliminate by this FMEA, so that whatever improvement you have taken, that will be giving your 100% result. You have to give the RPN number for that. Okay? So it is divided into 3: severity, occurrence and detection, right? So I have given severity as a S, occurrence as O and detection at D. And we have done similar 931 analysis, which is very simple, right? To give 1 to 10 number, it's very difficult. But giving a number from 9, 3 and 1, it is very easy, right? And we are able to calculate that. So in that, so severity means whatever change you are doing it, right? And that change will affect your quality of the product or the process capability. That you have, if it is affecting highly, then you have to give severity as a 9. If it is lower, you go for the 1. Occurrence means it will give the repeatability of occurring same event. It is occurring many times. If it is yes, then go for 9. If it is occurring once in the blue moon, go for 1. Detection. Are you able to detect that failure or not? If you are not able to detect that failure, then go for 9. Because at the end of product, you will get that effect and it is unnoticed and it will affect your quality. Then that is a highly recommended action that you have to have a detectability of 9. And lower, you are detecting it easily, then go for, that will be the lower effect. That means it will does not have a significant effect, you go for 1. So like that, we have to give the RPN number. Multiplying everything, you will get the RPN number for that. So like this, you have to perform this FMEA, failure mode analysis, effect analysis for your project. So that whatever change you are making it, that should be recorded. And the failure, what will fail my project, you will come to know. And you will take an extra precaution for that. Right? So it will not affect your desired outcome. So FMEA is very important. So you have to do that. Then comes the control phase. Now whatever implementation you have done, what is the effect of that? We have to go for the control chart. So I will just show you what kind of effect we have achieved. So this is about, sorry, I'll go to second part. See, so this is about where we have turned it. So improvement factor. Okay. So where, see here. So earlier we were not getting a capacity. Okay. Timing were higher. So we have reduced this timing from 17 hours to 13 hours. So hence we are getting the higher capacity. Also AISP, we are getting a capacity of 142 metric ton. This is in kgs, right? 142 metric ton. Earlier we were getting around 104 metric ton. So because of improvement, it has increased. So we can see the individual, whatever AISP batch cycle time we have reduced. Earlier it was 16 hours. Now we have reduced to 13 hours. So variation also decreased. Earlier there were larger variation in the batch cycle time. So here for the ISP, it has raised to 19 hours, 20 hours, and we have bring back to the 13 hours. So like that, we have removed or decreased this cycle times. And see, the productivity has increased to 134 metric ton per month. What was our target? It was 130. And see, it goes on increasing. This is for the FY17. And see, after doing all the things, it has steadily maintained to 131.5 metric tons per month capacity. See the variation? There's no such variation. We are delivering the deliver the project of 130 tons, and with the less of standard deviation. We see the standard deviation over here and see standard deviation over here. None. Right? So this is the way we have to perform our project and put our result, whatever outcome is there in the project, so that the team who is analyzing you, they will get the exact target what you have achieved. And then we have to perform this hypothesis testing. Whatever change you have done, is it sustainable or is there any variation? Just hold it.
Sir, you are on mute.
Sir.
Yeah. So, are you able to hear me?
Yes, sir. Yes, sir.
Yeah. So, after doing the improvement, we have to go with the 2 sample t-test. Here, your mean is checked, and the indication for that is mean is changed is your p-value. Is it significant? This p-value should be less than 0.05. So it is 0.0. That means definitely the mean is changed from 104 to 93. Median is 104 and it has reached to 131. So that is a sustainable change. And then at the end, you have to finalize your project data and get it vetted from the finance department. So here we have save up to 35 crores of money from this project and get his signature from the finance department, and hence the project approval from the site head for that particular plant. So like that, you have to complete your project. So this is the way you have to conduct your project, right? And for in control phase, you have to sustain. So you have to have a proper documentation for same. So what should not be changed? If you have changed the process, so you have to change the SOP for same. So controlling parameter, you have to make it perfect. Okay? And this control chart you have to put in. So this is all about how you have to conduct a project at the industrial level, what kind of data chart you have to prepare, that we have seen from the live project what we have conducted in organization. Thank you.
Students, if you have any doubts or any question, one by one you have to ask.
Yeah.
Okay, sir. Anyone have any doubts?
So basically, yeah, I will just add. If right now you don't have any doubt, you just write it me through email yogeshkoparkar@gmail.com. Any help is required in your project or any support is required, I will be there. Okay? So main thing is that we should have a clear intent how we have to perform the project. The DMAC last, I can say 10 years, I am working with the DMAC philosophy, and it has taught me a lot of lessons. Data analysis is the key factor that will give you the what you can say, the bit rate of your process. Like we are doing ECG, you will get the control chart, right? And that ECG, whatever peaks are there, if it is abnormal is there, doctor will say there is a problem. Similarly, if you do a data analysis like control chart and or the capability analysis, you will come to know where the process is moving wrongly, and that is very important. In future life, when you go for the industry, just take a data, analyze it. This is a good platform what you are opted, and this will give you the one step ahead of others to understanding how the data is behaving for finding out the solution for the problem.
Anyone have any questions?
Sir, I am Mohit from IIT Nilange. Sir, I want to ask that how do we set our targets in the define phase? I mean, we
Absolutely.
anything.
Very important topic. See, there are, when you are selecting a target, it may be a design, process design, what you have got it. Now plant capacities, design plant capacity is your first outcome. So from that you can leverage achieving 80% or 85% of your design capacity. Mostly the plant are operated at 80% capacity. But sometimes happens that you are moving higher than capacity, right? In that case, the first case is the design, right? Design capacity. Next stage is for the chemical process, basically, what is the theoretical yield you are getting it. So that will be your target. For example, if you consider, say for what is the example I can give, because if say X process, right, having the conversion rate, theoretical conversion rate is of 85%. Okay? But in practical, you are achieving only 75%. So there is a 10% of margin, you can go up to 85% conversion. So that will be your target first. So you'll divide in 3 phases, right? You will move to first 80%, then 80 to 85, right? If you are doing engineering, because there are 15% which are lying. So finding out how I can achieve up to 100%. So that will be your final target, right? So it will come from the, one is from the chemistry, one is from the design of the process, what the people has designed that process. So like that we have to opt a target.
And sir, does it happen that we start a project and we fail to achieve the target?
Just can you repeat that?
Sir, I'm saying that we start a project and we fail to achieve the targets.
No issue. See, something you have learned, right? Failure is next step towards the learning, or next step towards success. Failure will teach you a lesson. Take that lesson and move forward. There is no, see, in Six Sigma process, we are not considering a failure as success. We are doing the continual improvement. Why I'm saying that? Because if you are not achieving a target, then something that you have not noticed, right? That thing we have to particularly find out, okay, why it is happening, and learn that. Many times I also failed because we have conducted a project but we have not got a desired output. But the desired output, why we have not got a desired output, that we have to study and find a solution for the next project. See, always all the researchers are doing 100 experiments. Only one experiment is getting succeeded, right? And that is the breakthrough. So that is the kind of work we are doing it. So never you think about success or failure. We are thinking about the continual improvement, right?
Okay, sir.
Anybody have any doubts? Students, now you can put your cameras on. As per Yogesh sir said, we can
Yeah.
take a snapshots.
Absolutely. So
All I request is to please put your cameras on. Sir, can you please stop your presenting your screen? Then I'll take a
okay. Just wait. Yeah.
All I request you to please put your cameras on. We're done.
Thank you. Any help, anything, just write it me on email yogeshkoparkar@gmail.com. I will answer your questions. And any help required in this Six Sigma journey, I'll be happy to help you all.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Question.
Thank you, sir.
Thank you, sir.